Okay, for this first part of Red Planet Odyssey, we will be putting together the STEM rover. The things that you will need is your rover kit, the directions, and if you have cling wrap or saran wrap, that might help us put the little screws in, and I'll show you that little trick when we get to that part. So you'll also need that if you have that in your kitchen. First, we're going to unbox or unbag our kit. You can see how little those screws are in that kit, so be careful that they don't roll away on you. And you'll also need 2 AA batteries when you're done with your rover to go in here in your battery pack. All right, I'm going to open up our directions. Step 1, we want to put the axle through our breadboard. So I like to orient myself. So you can see I have this square kind of shape here, circle, and then a square in the middle. And if you look at your directions, that is exactly how it is in the directions. So I hold it the way that it is in the picture to help orient myself. And I'm going to put the axle through these holes at the bottom here. Okay, and then the gear we're going to get is this one right here. So to install the gear, you need this gear with the knob there and the one long screw that you have. So make sure, as you can see in the directions here, the top of the screw is going to be in line with the knob coming out of the gear. So I'm going to use my little screwdriver way through. Again, when I pick this up, I'm going to orient myself. The gear is going to go on my left in the second hole over. Switch hands because I'm right-handed. I'm going to screw that down nice and tight. But not too tight. I'm going to loosen it actually just a little bit because I want this to be able to freely move. So loose enough that it'll freely move, but tight enough that you don't have to worry about your screw coming out. So again, we're going to go into the second hole over. You want the knobby part facing our large gear onto an axle. So you can see this has a little knobby thing. We want that. When you push it down on, we want the knobby thing closest to the end. So when a wheel goes on, it's just barely fitting. So the knobby thing is on the outside part. I'm going to actually switch axles since I used this one to put it on. And then when it goes through, it should align with that gear. So when I turn the wheel, this gear here should turn. And that is how gears work. So one thing is motorized, and we didn't add the motor yet. When that gear is motorized, it will actually make all 3 gears that we add to our rover turn. Okay, this is our motor. This is our last of our 3 gears. We are going to add that gear to the end of the gear shaft on the motor. When you're putting these gears on, be very careful. You don't want to push too hard. You can try both ways, see if one way goes the other with this one. But these are very tight fit, which we want gears to be. because we want, if the axle turns on this gear or the gear shaft turns on this motor, we want this to turn. So go ahead and push that on. Just be very careful. And this is the bracket that's going to hold your motor on. So that's going to go over the top. You can see here on one side of the motor, you have places for your wires, which will connect your black and red wires to there. So you want that up, and then your bracket to go over the motor. So my wire, where I'm going to connect my wires, are here, and I'm going to connect my motor like that. Now, you want to make sure wherever you attach this motor that it's going to touch the gear. That is the most important part. As I said before, the gears only work if they're all connecting to each other. And this is where your saran wrap will come in handy, because these screws are very, very small. So if you take a piece of saran wrap and take one of these tiny screws, and you're just going to push it through just so the ends of the screw comes out, but not the head. And then you can put your screwdriver on and pull the saran wrap. Oh, I pushed too hard. So I'm going to push my screw through. Put my screwdriver on and pull the saran wrap up and around. And that will help me hold on to that screw while I'm trying to screw it down. Okay, once I have all 4 screws holding down my bracket of my motor, I can double check, make sure when I spin the top gear, the smallest gear that's on my motor, it then spins the medium sized gear and the large gear on the wheel. So you can see when I spin up here, my wheel moves, and that's exactly what we want. We want all 3 gears to be in alignment. So when the one in the motor moves, the rest move. Just going to put my other wheel on at this point to hold everything in place. And now we are going to attach the battery pack. So the battery pack is going to go according to step 4 on the back of your rover. And you can put the wires down one side and then come back up through the hole near your motor before you attach it. And you don't want your wires to get bent, so I am moving it as close as I can to that so they can go freely down without getting bent, and then also aligning the holes up. So again, you're going to use a piece of saran wrap, small screw, hold it up and around my screwdriver. You want to use the last hole here to attach your first screw, and that will allow you to move it back and forth a little bit, left or right, to get the screw holes to align. So after I get it started, screw that down nice and tight. And having it there allows my wires to come out without getting bent here. That's important. Then we can attach one more screw to hold it all in place. Okay, now my battery pack is secure on, and you have this switch here that will allow you to turn on and off your rover. The next step is to attach our wires to our motor. So if you have this oriented as the same as the picture, so we have our motor here to the left with the gears facing away from us, the battery pack here, and the motor is upright with the 2 tabs that we're going to attach our wires to on top. What I did is I just took my fingers and bent those up very gently, the tabs that we're going to put our wires through, which will make it a little bit easier. And then go ahead and give your wires just a little bit of a twist so they stay together instead of fraying. The red wire will be attached to the right side. So you're going to go through that tiny little hole. As much of the wire is in as you can. And then you're going to double back the wire so it attaches to itself. So you're going to go through, double back, and then twist it as best you can around itself. So the wire twisting around the wire. So you have a good connection there. You don't want that to come loose. So bend the wires so they're nice and tight against that conductive metal. And then you're going to do the same with the black wires on the left side. So I'm going to go through, twist the wires as best as I can, kind of bunch it all up around that conductive piece of metal. Okay, and the last part of building my rover is I want to put the last axle through and my last set of wheels. Okay. All right, and there's our rover. And last but not least, we will add the batteries. So here I have 2 AA batteries, 1.5 volt. And the way batteries go in, if you actually turn and look at this, it has a positive side, and that's generally where the knob comes out, and a flat side, which would be the negative side. And that's just telling you the way that the electrons flow through the battery. And to do this, make sure your switch is up in the off position. You're going to put the flat side of the battery against the springs, push and snap down. And the same with this one. Flat side of the battery against the spring, push and snap down so they're nice and snug. And this is our true test. When I take this switch and put it down and touch, my wheels should turn. And mine doesn't. And that's okay. That is part of the design process. We need to now debug or troubleshoot. So maybe my wires aren't connected correctly. So I'm going to try that. See if my wires are nice and connected. Make sure my switch is in. Make sure my gear is not too tight. And that's what it was. My gear, everything was correct, but my gear was a little bit too tight up against that other one, not allowing it to move freely. So I need to move this around a little bit so it can get right in the groove there. And allow, maybe loosen up the wheels a little bit, pull them apart so there's no resistance against that gear. And try again. So you can see not every time is going to work correctly, but we have to figure out what went wrong. So things that could have gone wrong was maybe it didn't have a good connection when the switch was put down, because the metal to the metal is what's going to make those electrons be able to move through both batteries, going through the wires to the motor. So that could be the issue, the switch. We could have put our wires on backwards, so you could check there. Or like I did, that gear had too much resistance against it because my wheels were too snug together. So I loosened up the wheels, allowing that gear to move more freely. And then when I put my switch down, my rover moves. Okay, so the next thing that you can do I'm going to show you with this gear, this rover. It's not fully put together because I took the wheels off and it's missing a battery here. But you can add some fun stuff. So this might be like a roll bar. If it's going up a hill, it won't flip over. So you can make changes to your rover depending on what you have maybe laying around your house. So this is just a piece of a tractor that we had at our house that we added with a zip tie to give it more stability. You can do that now. And the next thing we're going to do is pull out the mat and design our rover and pathway so it can accurately get across Mars.
Hi everybody, my name is Jamila Walida Simon and welcome to the Red Planet Odyssey Part 2. So we introduced you in the first part to the concepts of engineering design process through building your rover, and now we're going to go on a small exploration. And this is the exploratory part of our mission to Mars. And this activity is really going to design on the engineering, it's going to focus on the engineering design process for both building and exploring. So one thing I just want to point your attention to is that NASA has been exploring Mars since 1964 through missions that fly past the planet, orbit, land on it, or explore the surface with a rover. This activity is named for the Odyssey mission, an orbiter that's been taking measurements of Mars for more than 18 years. Part of NASA's Mars Science Laboratory mission is Curiosity, a rover mission after which another Mars base camp activity is named. And Curiosity is the largest and most capable rover ever sent to Mars. It launched on November 26, 2011, and landed on Mars 254 days later. Curiosity set out to answer this question. Did Mars ever have the right environmental conditions to support small life forms called microbes? Early in its mission, Curiosity's scientific tools found chemical and mineral evidence of past habitable environments on Mars. It continues to explore the rock record from a time when Mars could have been home to microbial life. So why the engineering design process, right? We're going to get ready to play, and I just want to talk to you really quickly, right? So you took some time to assemble your rover, and now we're going to take some time to do what NASA engineers do, which is to ask questions, imagine solutions, design, create, test models. And so the engineering design process is more of a cycle, right? The steps can be done multiple times as engineers really look to refine the solutions that they put together and get closer to their goal. And that's the goal of our time together today. So not every step needs to be completed each time, but we just want you to be mindful about how you can be successful in your mission. So the first thing is to ask yourself, what's the problem, right? What does it require? How can we meet the problem? What constraints might be involved? The second part is to imagine, right? Brainstorm solutions, try things out, get it right, try again. Plan, right? Choose 2 or 3 of your best ideas that you've worked on in your brainstorm list, sketch out possible designs, and then choose a single design to prototype. And you'll see in the rest of the video, I've prototyped a few different things just to give you some ideas that are really thinking outside the box. Then we want you to create a working model. Take that model, see how it works out for you, see if there are any hiccups that you come across along the way, and if so, try it again. And then the final part is to test, right? We want you to examine the solution that you've put forward, collect and analyze the data, summarize its strengths and weaknesses, and then we want you to improve on it. And so you'll see in the next couple of videos that I've not only collected some materials that you might find in your household, I found some unusual materials as well that you might want to try out. And our time together, we're going to build and explore. So let's see how I've built and explored and looked at this cycle of asking, imagining, planning, creating, experimenting, and improving. Welcome back. So you can see our rover is situated right here. And as we play, we can find and brainstorm supplies that we might need. Sometimes we think of rubber bands, tape, straws, craft sticks. Sometimes we don't even have to go very far in order to figure out where we might be able to land and what we can create. So here you'll see, right, these are all spices. So we can keep it spicy as we do our build and create an opportunity to create a space, right? Almost like a space for our rover to go. And so if we think of this as the starting line and out here as being the finish line, let's see how spices compare to everything else. Looks like it worked okay. So maybe you might dig into your pantry and find something. I did try this with flour. I don't recommend trying that at home. Contain whatever you're working on. You'll find some other details that I've utilized from the pantry that create a little bit more terrain. But be thinking creatively about what supplies you have around your house and what you might be able to put together in order to be able to explore. The point is, your rover will keep going. It doesn't have a sensor, but we want you guys to really brainstorm and play. Figure out where your starting and your endpoints are, and then try out something. If it doesn't work, you can always try again. That's what I'm going to do. So come right back so that you can see what else I've tried. Hey, so you're back again. This is my second take. So we're exploring again. What did I find this time? Sweet potatoes, right? Maybe we could use sweet potatoes in order to create our exploration and see how we do, right? We can keep it as open and as flexible as possible. We can use cardboard boxes. We can modify our actual rover and make sure that our batteries stay intact by putting a rubber band around our rover. We can tape our batteries in. And again, we can use everyday common items. We can use paper towel rolls. We can use gift wrap. We can use all kinds of things. So let's see how this take actually worked out for us. So similar sort of thing. We still made it from point A to point B. The point is you can use just about anything to create this. The sky's the limit. Have fun with it. And also be thinking, how do I get from point A to point B? Am I only moving in a straight line? Would I like to have curves? What's going to send the rover in a different direction, right? Again, without sensors, we have this really amazing opportunity to create solutions, to brainstorm, to see things that maybe we didn't know were going to happen, and to integrate that into our design. Welcome back. This is my take 3. This time I wanted to mimic and create an opportunity for some rough terrain. And so let's see how our rover does in a little bit of a rough terrain. What you'll see down here is just some regular white rice. Again, these are extra staples that I had in my home. I'm not encouraging you to waste food. You might have paper clips that you can put down. You might have something else that's going to mimic that terrain. You might have tissue paper, right? How's the rover going to perform in those conditions? Well, you can see here it didn't do very well. And your rover, we want it to be constantly in motion without having to attend to it or to touch it. So this was a little bit of a fail, right? Thank goodness I had a surplus of rice and I could spare what was here for this rover project. Again, I don't recommend that. But let's think about some creative ways that you can create that terrain. It's not just a flat plane that a rover is going to be perusing on. So we do want to create that opportunity. The next video, we're going to challenge ourselves and perform this at a height, right? And see how our rover does. So this is our last take, and right here you'll see the rover is on my counter. And we want to see how far it can possibly go. Again, the terrain is not going to be flat. There will be some heights, there'll be some depth to your activities, and you want to challenge yourself as you go forward, right? We started off with just a plain terrain with the spices. We moved on to the yams again, still pretty plain terrain, although there was a little bit of a twist and a turn. We moved into the rice. Let's get some height in here and see how this rover performs. The goal is for you to challenge yourself. You're going to encounter obstacles like hills or craters. And so this is the time to really familiarize yourself with the terrain and what you might actually see. And so you're going to need to design a rover that can withstand some bumps, some jarring. And once your rover is built right, you're going to create this physical pathway that's going to be your guide path for how the rover is going to move from the start to the finish on Mars. So let's see our last take. And this just gives you a sense as to it's going to be rolling off of a counter and down a chair, and then potentially down the chair and continuing from there. Let's see how it does. And it's down. And it sounded as though the batteries might have rolled out. So again, we can make those modifications and tweaks. We can tape down our batteries. We can make sure that it has a soft landing, right, by creating some other opportunities for some dimensions there. But our whole purpose is to make sure that you have this experience to build and explore. This is all a part of the engineering design process. Again, beginning with that asking, moving into imagining, creating your plan, then enacting that plan, experimenting, and improving, right? Improvisation is really huge. We want to take this time so that you guys have a chance to play on your own and share with us what solutions have you come up with and how's your rover doing.